Hello everybody, welcome to the stream. Make sure audio is on. It is. I'm James, Bald Engineer, you're you, and we're going to get started. So, yeah, let's just go straight, let's just get right into things. Bernardo from the Byte Attic sent me something called the CERBERUS 2100. Cerberus. I don't know why, but pronouncing this name is giving me like anxiety. Essentially, this is a board that has a, let's see if I can get them right, a 6502 or a modern WDC 65C02 and a Z80 processor that are then stitched together with three CPLDs, where one of the CPLDs is handling the video. And so what's really cool about this is you can reconfigure the computer by reprogramming the CPLDs, which I haven't even opened it. I bought one of the programmers for the CPLDs. It's like the ATF, what's the series? ATF 05, I think. They're 5 volt compatible CPLDs from, well, it used to be Atmel, now it's Microchip. So anyway, that's the part I'm really looking forward to, but I haven't quite gotten there yet. The other thing is that this board has a expansion slot, so you can plug in other hardware. And this has the address and data bus plus clocks, and I think a couple other signals. And I just couldn't help but think, man, wouldn't it be nice if I could just plug my digital discovery directly into it, like some other projects I've done? So what we're going to do tonight is design a board that will plug into this expansion slot, provide a new socket for a card to plug into, and then also a socket for a logic analyzer. I'd like to do a 1-to-1 where it's just like 4 or 3 40-pin headers, and then I also want to do one that the digital discovery could plug into. So let's get those going. All right, so that's what we're going to do. I put a link in chat. Let me make sure this works. To the CERBERUS 2100. If you want to learn more about it. I should have mentioned this at the beginning. Well, I did mention it. So Bernardo sent one of these to me, free of charge, free to me. And so while this is not a sponsored video, I did receive something for compensation in terms of, or I did receive something to create content. So technically it's compensation. And so if that bothers you, I'm sorry, but you know, he offered, I took the offer, and I'm really glad because this is a really cool computer. With that, let's get started. Okay, so I've already created an initial project which has nothing in it. So let's go add stuff to it. Oh, you know what we need? We're gonna need the pinout. So let me go grab the file real quick. Projects, retro, Cerberus. I keep wanting to say CERBERUS for some reason. Like I just cannot. My mind just doesn't want to say the correct word, and I'm still not convinced in my head that I'm saying it correctly. All right. Okay. So the manual, which I think he did in like Google Slides or Impress and Star Office or maybe PowerPoint, looks like a whole bunch of presentation slides put together, which, by the way, I shouldn't sound like I'm knocking. I'm not. I just think it's interesting. That's one good way to, that's one approach to take. It's unlike another retro inspired computer I received recently. This documentation manual is done very well. I'm very happy with it. I think it could be a little more detailed in a few places, but that's pretty decent. Okay. So it's the ATF 15XX family of CPLDs. So this board uses the 1508, and then I think there's a 1504 that is in a kind of a smaller package, less gates, stuff like that. So, hey, Sam. All right, so what I'm looking for in here is the expansion header. Oh, I forgot. I was going to show it to you. Let's do that. Let's do file, open capture device. We want this one, advanced options. Nope. Show more. I want to disable caching. All right. And then that should get us. Oh no, why can't you open it? Okay. Stop. What is wrong with that? Oh, I wonder if it's because OBS took it. Oh, womp womp. Let me try this real quick. Let's do video capture device. USB adapter. Yeah, that's what happened. Okay. So I'm going to hit F12. Let me move this down so that I still show up. This one. Okay. So I hit F12. So just a couple of basic things. So it starts up as a Z80. You can type fast. And now it's running from 4 megahertz to 8 megahertz. And then we can type 6502. So now it's running at 8 megahertz on a 6502 WDC modern version. And so we can slow that down. And then there is a micro SD card, and it can have a bunch of files on it. I haven't gone through everything on here, but Bernardo does have a good video that goes through the basics. Speaking of basics, basic for 6502. There we go. Now we're in a basic interpreter, so we can do 10 for n equals 125. Oops. 20 print hello chat. 30 next in run. There we go. So kind of neat, huh? So far, the only thing I don't like, and this is relatively minor, is that he's using a PS2. Okay, tell you what. Let me find the page I need. Okay, this is the page we need. This is page 49. Okay, and now I'm going to go back to the first page because I'm looking for the picture of the board. Yeah, so the only thing I sort of don't like is that the keyboard uses a USB-A connector, but it's the PS2 protocol. So you have to have a keyboard that is PS2 by default, and then it uses, I'm not going to pull it off because it's green, you won't be able to see it. But it has to be a PS2 keyboard that has an adapter to connect to USB, even though it's actually just passing PS2 over the USB connection. It's really a popular standard for FPGA based stuff, like the Fleom FPGA that well, there's another FPGA project called the Fleom, which is mostly an emulator for Amiga. It's the same thing. So yeah. So another board we might make is something that plugs into this that uses a RP2040 to convert USB into PS2. So okay, so like I said, this is the connector, the expansion board connector. So we're going to make an adapter so we can plug a logic analyzer into there. So let's go to page 49 and make this more bigger. And then let's see. Yeah, let's do something like this. Move that over here. Move that over to here. And then I can scrunch that down a little more. And we'll see how many of the signals do I remember the correct name of. Oh, I'm blocking some of it. Oh, that might be okay. All I'm blocking is a bunch of ground pins and maybe data 7. Okay, so let's come over here. Hey Shark, how you doing? All right, step number 1 is I didn't actually verify how many pins this is. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, it is 40 pin. All right, so let's create a, wait, USB keyboard mouse to PS2 converter. Interesting. I'm actually wondering how difficult it's going to be to go that direction. Because I know there's lots of libraries out there that will act as a host for a PS2 keyboard. I don't know how many out there will act as a PS2 keyboard. I would assume that that's easy, but I don't know. All right, so we need a connector, and I want it to be 2 rows with 20 things. And then I believe we want it to go odd even because of how the footprints work. So let's select odd even for the moment. And then let's hit F. Oh, I can put my inputs back on. There we go. We'll go into the library. So by the way, this is the one thing in version 8 of KiCad that I hate. like literally hate it, is they replace the footprint browser, which to me is a far superior method for choosing footprints, with a footprint chooser, which is similar to the schematic symbol chooser. I think this is dumb. I liked it better before, where you had a first you filtered the type of or you filtered by library and then within the library. So like it was just easier to me, because then you could do like, I could say, oh, I want a 2.54 header, and then I would select the correct library, and then you could filter on the part. I just think this is dumb. So not that I have, well, actually I have a very strong opinion on this one. I think this to me was when I realized that they had made this change, I was actually kind of irritated. And it was like the day after I published my 8 things about KiCad 8 that I like, because I hate this. This is there's multiple reasons this is dumb, and this is my primary reason to hate the footprint chooser, is you don't have the measurement bar. So you can't do quick checks to see, is this the footprint? Does this footprint match what I'm looking for? I just don't understand why they thought this was a good idea. This is just the dumbest change they could have. I just hate it. And I think what really irritated me about it is the response on the forum was, well, why don't you just do a bunch of feature requests for what you want? And it's like, well, what I want the footprint browser back. So why not make the chooser an option until it's back to feature parity with what's already available? Like, that makes no sense to me. Okay, I'm done ranting about that. All right, so we'll call this the CERBERUS expansion. Oh, let's go ahead, and since we're not doing a bit preserve project, let's turn automatic annotation back on, because I don't think we're gonna really care. All right, let's see. Let's go ahead and get the symbols named now, because we'll be reusing them over and over. And it looks like XBus rec is going to be about the longest. So we got 1, 2, 3. All right. So then I'm going to do a wire, and now we're going to use the insert trick to fill up the wires. All right. I'll copy and paste. I could actually probably just copy and paste all the wires over, but that's less fun. All right. So there we go. We got all of those. Let's identify the ground symbol, the ground pins. So ground, and then I think only these 3, which you probably can't see. This is page 49 if you want to open up the PDF yourself. There, you can find it in the link above. And then there's no ground on the other side. Okay. Yeah. Why did the FPGA kind of standard move away from just using a PS2 connector? I'm sorry, Tomas, I don't understand what you're asking. I don't particularly, I think the primary reason FPGA and CPLD stuff uses PS2 is because it doesn't require a differential transceiver or bus driver. And so you can do it all with single-ended signals. And I would imagine at this point, there's no IP restriction on PS2. I'm not sure if there's an IP restriction on USB, but I wouldn't be surprised if there is. But I think the primary reason is because because USB requires a quasi-differential driver. Even though you can kind of hack a way to make it work without it for HID devices. Wait, isn't the D in HID device? Human interface devices? Yeah. All right, XREC. Okay, let's do XBus ACK. So I did write a program the other night on this computer. Actually, before I forget, I'm going to unplug it because I don't have it in its case right now, and there's a bunch of stuff on my desk. I don't want to accidentally explode it. All right, let's go ahead and get all of these others identified because it's going to make it easier once we start doing the data and address bus. I'm going to do those last. Well, I think like in the case of like this computer, it's the keyboard's implemented sort of like how the Apple II does it, where, well, the 2GS does it, is the computer itself has no idea what kind of keyboard is connected to it. It just knows that it requests data from a certain address and 8-bit shows up on the data bus, right? And so the thing that does all the stuff, does all the USB stuff or the PS2 stuff is probably not even visible to the rest of the computer. And so I don't think it's necessarily a driver thing. I think it's just, like I said, I think the biggest thing is now I think about it is, so there's probably not a differential transceiver. And so you would have to have a Mac, a media access controller, which is probably not easy to find anymore for USB. Or wait, no, you only need a PHY, the PHY, the physical layer interface, which would then connect to your CPLD instead of a Mac. And finding those discrete components now are probably pretty difficult. All right, so I think 7, all the odds are over here. So I'm going to move these over here. I'm going to X to move them over. I mean, at the end of the day, it's like if I was going to list the reason to not buy this, the fact that it uses the PS2 keyboard is not, it's not that big of a deal. It is a little bit awkward to me that it's using, what did I mess up? These are all in the wrong place. It is kind of frustrating to me from a usability perspective that it uses a USB port. But what are you talking about? You're not going to... No, you're not. I had Windows Update disabled. God, do I have to Why is it every time Windows Update runs, I have to do like 7 things to disable it? Hold on. This is like... I hate this because this computer should never restart unless I tell it to. I can't tell you how many times I've gone to bed and I've started some big project to render, go to bed, and then wake up, and it stopped halfway through because Windows decided it was time to reboot for no reason. Well, but that... Yeah, I mean, I see what you're saying with enumerating the bus and stuff, but Tiny USB does it with very little issue. I mean, that's why when I did the Mega 2, I used the RP2040 to do a keyboard interface because I didn't want my computer to use a PS2 keyboard. I wanted USB, so... Okay, now we'll do XD0. And then, I get it. The PS2 method is slightly easier from an implementation perspective, but it makes for a lesser user experience because it's not as easy to find PS2 keyboards as it once was. It's not impossible, but it's not. And then also every time somebody talks about PS2 keyboards with the USB connector, there's always someone that spreads the misinformation that all PS2 or all USB keyboards can speak PS2, which isn't true, or that the adapters do any kind of electronic conversion. That's not true either. They're just mechanical adapters with electrical pass-throughs. So the keyboard has to support PS2, period. And no, not in fact, I would imagine any keyboard you can buy at the store today does not support the PS2 protocol. I would be surprised if there were any that do, without explicitly saying that they do. Like I could maybe see somebody still sells one, but like you're not going to buy like a $15 keyboard at Micro Center and USB keyboard at Micro Center and plug it into a PS2 port. 1012. 024655xn ground 75321 ... Okay, let's commit that because we may want that later. So first we will we're going to ignore this. Auto saved files. Okay. And then we're going to, oh man, I already had git ignore in the ignore. So why is that showing up? Bummer. I don't know what I did wrong. With this extension. Okay, fine. Ignore that file name. I don't know why that showed up. Okay, whatever. Yeah, back in the 90s, especially when the USB conversion was happening, I would say up until about 2000, just about any keyboard you bought supported both. And then I would imagine around 2000 is when that started going away. Yeah. And I would imagine after 2005, that's probably anything made before or after anything made after 2005 most likely doesn't support PS2. Let's just go initial expansion connector layout. But I don't know. There's probably a Wikipedia article somewhere that disputes everything I just said. So, you know how it goes. Oh, tomorrow, Friday, there's going to be a new Element 14 project video from me using the Nordic NRF 7002. It is a spoiler. It is a Wi-Fi LED detector that did not go anywhere near what I expect it to in terms of a plan. All right, so now we're going to just move this to be over here and this one to be over here. And I kind of wanted these to be even. So this will be the expansion card, or I'll just call this card header. And then this will be the logic analyzer. I'll call this the LA header. All right, so this one, I did this as a socket, correct? Nope, I did it as a header. Because I was too busy complaining about how I don't like this dialog. I wasn't paying attention to what I did. Pin socket 2x20, yep, that's what I want. All right, so we'll save that. And then over for the card header, okay, well that works out because then that stays as a pin header and this will be as a pin header. All right, well that's all I know one other thing we need to do. We need to decide what we want to do with X clock. So how do I want to do this? Let's add a con 01 X03. So X clock, if I understand it correctly, which there's a good chance I don't, not X clock, what is it? Maybe it is X clock. There is a pin that enables the buffers so that you can actually sniff the bus, but I don't remember which signal that is. Okay, so that's the address, that's the data, that's the clock. Bus acknowledge strobe, XE. XE is what I was thinking of, right? This XE enables the data and address bus transceiver so the expansion card can sniff the bus. All right. All right. So, well, that's not what I meant to do. Well, I'm going to actually hide that for now because I think we're done with it. Yeah. You have to wonder about anyone that sniffs a bus. So let's go XE header. And then we're going to grab this. And we're going to do that. And then I'm going to add a plus 5 volts. And we'll add a ground, even though we have text labels in the headers. I'm going to do this, and then I'm pretty sure, whoops, that should keep them connected. Let's do a quick DRC check. Power not driven. Okay, I don't care about that. That's fine. Because this is actually the power pin is right here. Okay, you know what? We will, for the sake of correctness, I will add a power flag here. And then I will add one down here. There we go. Ha. Now tell me that there's a power flag problem. Not driven by any... What? I just fixed it. Oh. Okay. Fine. We'll do that. Okay, now tell me there's no now you can tell me there's no more problems. Oh, give me a break. Oh, I want to try something. Since version 8 lets us do this, can I just do this? Not that. What did I just click on? Oh, I want to click on that. Yeah, nice. Okay, so yeah, so with version 8, you can finally just change power symbols, that you don't have to go create a custom symbol anymore. However, that said, I would prefer if we change all of the 5-volt stuff, all the 5-volt pins to be plus 5 volts. So here's what I'm going to do. I'm going to delete, 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 delete. I'm actually going to save that one. So I can go edit, plus 5 volts, copy, paste, and then go like that. There we go. All right. Oh, nope, that's not right. LED Wi-Fi exists outside of a lab concept. Yeah, so it's basically it's just a an LDR, a light dependent resistor. You place it over the LED, and then the microcontroller samples to see if the LED is on or not. And when it is, it sends a message over MQTT, which right now it sends a message to an MQTT broker where I have a Python script running so that when it receives a message, it then hits a webhook in Discord so that I get a notification on my phone. I'm using it for my dehumidifier because I want to know when my dehumidifier is full. So, which is ironic to me because I finished the project at the end of January and the dehumidifier hasn't filled up yet. So now a month from now, it'll be a different story. I'll fill it up. It'll fill every 6 to 8 hours, but in the winter, it doesn't fill like the entire winter. It almost the only time it runs is I think about once an hour. It runs the fan just to see if the ambient humidity has changed. So, just kind of like to suck in some fresh air to update its sensor or update its reading. Okay, now we're going to head over to PCB, and so let's do 1-to-1 stage. Select it. 1-to-1, 1-to-1, ready for PCB. See, this one's pretty easy because it's all straight up connections. The next one's going to be a little more involved because we're going to rearrange the signals so that this will plug into the digital discovery. Yeah. It's not a board that shows an LED in the presence of Wi-Fi, which I have seen those before, and I think those are cool. But I don't understand the physics enough to design a PCB pattern to react. Like at, what do you call it? DEF CON last year, I saw this one. Let me see if I can find it real quick. And I want to make something like it, although this one is already way cooler than what I could make. Yeah, that'll work. What are you doing? What are you doing? So it's a RFID detector, but it has this really cool antenna pattern, and it can detect 125 kilohertz, and I think 13 megahertz is the other signal. And so I think I think it's 13. Oh, there we go. That's better. Yeah, 13 megahertz and 125 kilohertz. And then it's got a little LED transistor. It requires no power, and so just the RF energy is enough to light up the LEDs, and it's really cool. And so I want to make something like that. More as a learning experience. So, it's like I'm not really interested in trying to compete with that design. I just would like to learn how to do it. So, I mean, any mini PCIe connector will probably work as long as the key is in the right place, because you don't really care about anything on the pins in your case, since you're not using any PCIe signaling. You just need to make sure that the key is in the right place and that the two sides have the correct number of conductors. I would actually go and try to get the schematic for that Seed Studio Raspberry Pi hat and just find out what part number they used. Cannot add J4, no footprint. Whoops. We need to go add a footprint here. See, this is, I guess I could do pin header 104. Nope. 103. I don't like this dialogue. This is so dumb. Okay. There. All right, now let's F8, update, close. Yep. That's kind of what I was thinking this should look like. I'm going to move this to be like up here somewhere. And then I'm going to change my grid to be 2.54. I'm hitting N, and if you look like right by my shoulder, you'll see the grid changes as I press N. There we go. Now I'm going to click, and then I'm going to move, and I want to go 1, 2, and I want to go move 1, 2, and then I want to make sure if we go here. All right, let's do this real quick. Let's move this down 1, move this down 1. I want to make sure these are on the 2.54 grid. I don't think these are. I wonder if I need to move this one first. Yep, that's what I should have done. All right. So now what I'm going to do is highlight all of these and then just say, actually I'm going to highlight these two and then go position to left so that I can grab J3. Nope, not reference. I want footprint J3. Move that 1, 2, 3, 4, 5 over. All right. I guess I could just do this. Align to the right and then move 1, 2, 3. Whoa, no. That's not what I want it to do. Because I need to click and hold, and I want footprint J2. I'm going to move that 1, 2, 3, 4, 5. There we go. And then these are all on a 2.54 millimeter grid, which is exactly what I wanted. All right. And then now this one, I'm going to go down to a 1.27, move that over because I want that center pin lined up with that for some reason. Oh. All right. Yeah, if you had a, well, I mean, arguably, even if you had a drain, you may still want something that could detect if the reservoir fills, because it would indicate that the drain is what do you call it? Clogged. And like in my case, I don't have a drain anywhere near where I can place the dehumidifier. Like the only drain in my basement is the accessible drain is, it means the dehumidifier would be sitting right in front of the stairs, and that it doesn't make sense. So, yeah, I wish I could just connect the drain. That would make my life so much easier. But like I said, I would probably still use something to detect if the reservoir filled, because then I would know that the drain is messed up. So, and I actually forgot to say something about that in the video, because I know people are going to put that as the comment. Why don't you just, it's like, yeah, okay, I went through all this effort because I'd never thought to just use a drain. Okay. Now, this is the less fun part. Well, okay, I know what we can do next. Let's just grab a polygon on the edge cut layer and then do this so that we can, we get to finally use a new feature. So I drew the polygon. Now I'm gonna right click and do shape modification and do fillet lines of like 2 millimeters. Oh, look at that. Super easy rounded corners. That is awesome. All right, 1, 2, 1, 2, 1, 2. Yep, that looks good. All right, so save. Let's go Alt-3 just to get a quick look. Oh, I need to move that header to the back. All right, and we're probably gonna have to make the polygon bigger. I just want it something for now. We need to actually flip this around. So I'm gonna click on the footprint and press F to flip, and then move it to there, because it's actually going to be, yeah, I guess I could have just moved the 3D model. Pin 1 in the middle footprint is on the opposite side. I'm not sure. I think this is still correct. Let me think about this for a second. Come on, Windows. Let's just, one day, it'd just be nice if you just worked correctly. You know? Like, let me do that and not freak out. All right. What I want it to do is open up this and look at this. Uh, 49. And make sure that X clock ground 5 volt. So that looks like how I want that to work. But I want it to look real quick at the, like, page 3. Okay, so that's going to plug into ground there, and that should be ground. Yeah, so I think that's right. Okay, so that's sort of the easy part. I guess the only other thing I should think about is, do I want a power LED? I don't know why I asked that question. I know the answer is yes. So let's go add an LED quickly. So let's come back over here. We're going to do add. I'm going to do C. Oh, no, not C. R0805. And let's just do one of these. And then I'll add LED small. Fill. I don't like the filled. And then we'll do this. And then I'll copy ground to here. And I'll copy 5 volts to here. And we'll do a line right there. And we'll call this one 1K. And we'll call this one green. Oh. Or, yeah, we'll just do that. No footprint for D1. Whoops. Also, this should have been power. Then let's edit this and go into the footprint. And we'll do LED 1206. Okay. That does actually work a little bit nicer than it used to. Okay. I just realized this. So if I want to change the footprint of this resistor and I look for resistor 0805, I'm starting to feel like I was wrong. That is a little bit better in terms of filtering. Is it on a timer so I don't get warnings at night? I mean, I shut my phone off at night, so it doesn't really bother me. In fact, I don't know. Well, I don't shut the phone off. I just turn off notifications. So, but if it does its job correctly, I won't go to sleep until, I will unfill it before I go to sleep. And it normally, I'll say normally, doesn't get filled overnight. Well, I guess in the middle of the summer, it gets pretty close. All right. Okay. So I actually changed my mind. I want this LED on the bottom, and I'll explain why in just a second. Well, actually I have two reasons now. One is it just makes for a much cleaner design, but okay. I am just going to add a rectangle for right now, and then we'll optimize that later. So I realized two things. One, put the LED down here. It'll be a nice symmetry with the enable header up there. But the other thing is I was just looking at where the 5-volt pins are, and there's a 5-volt pin here that I could have gotten to the LED, but I would have had to like done a via or something around clock, and clock in this runs up to 8 megahertz. So I'd rather leave clock and ground all nice and clean up here. So we can just tack onto the 5-volt lines that are down here. I don't remember what XN is for. That might be for data in. So yeah, it's not nearly as critical as the clock. Okay. Now, so we'll end up with something that looks a little bit like that. Yeah, that's looking good. Okay. I want to move this. I want to move this down here. So that's lined up there. Okay, save that. Okie dokie. So now we're going to go and create a whole, I wonder, man, you know, it'd be really nice. What I would really like is, could I figure out a way, if I paste these into PCB, what happens? Nothing. All right. If we go and open up Sublime and paste that in, oh, okay. We get labels there. I don't know what you're doing. And then if we add a text on, oh my God, text on the front silk screen, and we call it X clock. Copy this and paste that. Ooh, the UID is going to mess me up. If I take this out, can I paste this in? It'll get assigned one. Okay, so we can leave that blank. Okay, let me try that real quick. Copy this, click on text. What if I paste? No, that's not, that just pastes what it, yeah. Nope, paste still doesn't work. I'm not surprised. I don't know why that would work. I just was hoping it did. If I knew Python better, we could actually probably just write a Python script that takes these nets and turns them into these elements. Let me try something else. XA0. Does the insert trick? Nope. And then what about, is there a helper function like there is in schematic? No. Yeah, so actually the fastest thing I could probably do is just do something like this. I could actually just take, all I need is this. So let's do this and then do XDA, XA0 and XD0. And then let's do that to 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. And then do 2, 3, 4, 5, 6, 7. All right. And then I was going to do this. Actually, this is all I should have done because this is just as easy. And then do insert and then do 7, 6, 5, 4, 3, 2, 1. All right. Not how I wanted to go about it, but I'm not going to spend an hour writing a script to do something that took me less than 2 minutes. And then, oh, what? I can't paste that. Oh, I know why. Okay. All right, let's copy that and now see if we can paste. No? Oh, KiCad, come on. Why you gotta be mean? Oh, it's not letting me do it at all. Okay, what if I do this? No. Not even gonna let me try. Darn it. Is that why? Did I mess that up? Nope. Nope, nope, nope. Not gonna let me do it. What the heck? I can't get, okay. We'll just do it the hard way. Oh, okay. I don't understand why my pasting isn't working. Oh, this is painful. I don't want to do this. I guess the good news is I only have to type these once. This has got to be the worst thing in the world to watch. Maybe I should write a script. Well, but I don't know why my paste didn't work. So what am I going to write a script to do? I wonder if there's, like the Python API has like something where I could just do a for loop and insert stuff in. XA1. XA. Okay, let's do a copy 2. 3. 4, 5, 6. That's not 6. All right, 7. Hello, 7. 8. Oh my God, this is painful. I'm very annoyed that I did not figure out a faster way to do this. I feel like I know how to do this better than what I'm doing right now, and I just can't think of what I've done in the past. All right, let's save that. And then I'm just going to do a, just for the moment, align to left. And then we'll do align to left. Okay. And then I need to move these up a little bit just to clean that up a little. Now let's delete all of these. The nets tab. Yeah. I'm gonna look at one more thing. Nah, okay. That was not what I wanted to open up. Text, filter, graph, dimensions. Nope. Okay. All right. Whatever. We'll just keep doing it the way we're doing it. Even though I think it's dumb. Okay. So that should cover most of the signals. And then we're going to have... nope. What is the text command? Oh, Control-Shift-T. Oh, that's so obvious. XBus rec. All right. And we're definitely gonna have to rename those something else. We don't have enough room for that. Let's do XWR. Let's do XIRQ. We'll copy those over here in just a second. I will add X plus 5V. And we'll do an XN. Come on, where you at? All right. And then we'll copy and paste this. And paste that. Oh, we didn't do XE yet. All right. All right. And then let's do a Control-Shift-T, XE. And we're missing XL. Okay. All right. If we're missing any others, we'll pick them up as we take care of as we place the address and data bus. Yeah, we're gonna have to rename those. But for the moment, I just want to get the labels figured out, and then we'll mess around with them. Oh, 1.1 by 1.1. Wow. That is big. Oh, I see what you're saying. Yeah, and then you just do like, oh, yeah, I think I've tried to do that in the past. I never thought about how to make that happen. Yeah, we'll do this. Because basically, here's how I'm going to make what I'm going to basically do is place all of these and then use distribute evenly to line them up. All right, so we need the X addresses. Let's just move these over here for now. So I need 1, 3, 5, and 7. They're going to go over here. And then this one, we're going to move up to here. And then these two, we're going to move up to here. And these two, we're going to move up to here. Did I save this? I've got this bad feeling. Okay, we're going to move this up to here. All right. Right on. Okay, let's move these over to here and do the same thing. 9, 10, or 9, 11, 13, 15. We'll move those over there. We're going to clean that up in just a second. And then we're going to move this to here. Wait a minute. That's not right. Oh, I see what I did. Okay, that's fine. I'm going to clean that up in a minute. I just want to have these in roughly the right place. Okay. So now we can take these and do the same thing. We'll just kind of move these up. So I don't know if anyone follows like speedrunning stuff. So maybe like a month ago, Carl Jobs had a couple of videos about a Monster Hunter, I think, player speedrunner who clearly faked a blindfolded speedrun multiple times. And it was funny because when I watched the first video, one of the first things I noticed, or not the first video, the second video, but my first watch through of it, I was kind of like, the one thing I noticed was how the player kept accidentally hitting the Windows key. And I was thinking about that and I was like, wow, you know, it's like when I see and pay attention to everything I do, I accidentally hit things like the Windows key all the time. And it's like, but without watching the Windows thing pop up, how would you know? Like, yeah, I was just like, it's so clear that she's looking at something. So anyway, that's made me think of that. So all right, now ground I'm not going to mark. I am going to mark ground, but I like to mark ground with a white silk screen. So we'll do that in just a second. Okay, so XE X. Okay, so then the rest of these should be fine. So what I should be able to do now is make sure that this label is in the center of the pin, and it looks like it is. And they'll make sure the top label is in the center of the pin, which it currently is not. It is now. So now I'm going to highlight all of them. Oh, you know what? We're going to change one other thing. Now, I like to make my text 0.8 millimeters, but that's because I usually use OshPark. And I understand that the company I won't ever name doesn't work well below 1 millimeter. So what I would like to do is on other PCB text items, I would like to change the thickness. What is it currently? To 0.2 and see how that goes. Well, that's interesting. Why didn't that change? I thought that'd be PCB text items, right? Is it already 0.2 and I just don't realize it? No. 1. Yeah, so I want that to be 0.2. So then what is this considered? Edit. Text. I want PCB text items. Change the thickness to be 0.2. Square here means leave everything like that the way it is. And then click OK. What? What? I don't think it's footprint text items. Oh, I'm changing line thickness, dummy. All right. What were they? Speedrunning or I think the game was Monster Hunter, which from what I mean, I don't know much about the game in terms of competition stuff, but from what I understand is she's actually a pretty decent player to begin with. So why she felt the need to fake a speedrun multiple times is even more strange. So I don't know. That it's not a game that I'm interested in, nor is it the kind of streamer that I would watch anyway. So I just found it fascinating that it was so obvious to a novice like me that it wasn't real. All right. So now I'm going to highlight these. I'm going to right click. I'm going to distribute vertically. And yep, now all of my labels are lined up exactly the way I want them. So let's make sure X clock up here, that is in the, its center appears to be in the center of the, nope, it could come down just one line. There we go. Now its center appears to be in the center of the hole. And I'm going to come down here. And this one looks like it can come down one as well. And then we will, oh, nope. Then we will highlight all the things. Highlight all the things. Let's do a align to right. And then move those over. Oh, no, 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 you don't. All right. Align and distribute vertically. Let's just spot check a couple. That looks good. That looks good. Excuse me. So 1, 2, 3. 1, 2, 3. Yeah, it actually looks like the same spacing. That's lucky. Okay. So, like I said, I'll come back and do ground later. The reason I don't want to do it right now is because once I add the polygons, it generates a ton of D or C warnings. And I'd like to know before I add those that the warning, I'd like to know that everything else is okay. So now we're going to just copy this and paste it over here. Yep, that looks good. 1, 2, 3, 4. All right, let's move once over, and then we'll copy these and move them over here. 1, 2, 3. I might still be one off. 1, 2, 3. You know what I just thought of? I was just thinking, let's look at the 3D because this might make more sense. So this one is where a card's going to plug into. This one is going to be for the logic analyzer, which I feel like the logic analyzer one you would want to be highlighted so that it's easy to read it. Or silk so it's a little bit easier to read. But I wonder if it'd be better if we just put the silk on the middle, because it will be unencumbered most of the time. I'm going to save this. I'm going to try that and see how I feel about it. So I'm going to delete this one. I'm going to delete this one. I'm going to copy this one, and we're just going to, not going to super careful place it at the moment, even though I just did. Let's go and grab this and move this one over to here. I didn't mean to save. I actually think that makes a lot more sense now that I realize it. And then we can make the polygon come in a little bit because it doesn't have to, it wouldn't have to really support anything else. There. And we can bring this one in as well. Let's hide those. I'm going to move this to here. Actually, I'm just going to put text on here. All right, I think I like that. Ground I'm going to highlight with a polygon. I'll show you what I mean in a minute. Yeah, I actually like this better. Or well enough, I should say, because I mean, it's a little confusing because this pin right here is not X clock, it's the pin over there. But I think you can make that one-to-one map a little bit easier. And it just makes the board smaller and cleaner. So, all right. Okay, so let's continue. Let's go set up some ground rules. I'm going to import settings from another board. This, by the way, for board setup and design constraints and net classes, you can, in the board setup menu, there's one for schematic as well. There is import settings from another board or schematic. And I just so happen to have Oshpark set up as a 2-layer board. And I'm going to import the custom rules, net classes, design constraints. Actually, I'll just import everything. I might have had the colors set up. I can't remember now. All right, and so now my clearance, my track width is already set to whatever that is in mils. I think I changed the colors, didn't I? I did. Nice. All right, so then I can save this, and we'll do an Alt-3 one more time. Yep, and so now we can see purple board. Not that it matters. It just looks nice. All right, so now we're going to do a little bit of routing. And I think what we'll do is, let's see. Let's make our default trace be 8 mils and see if we can make that work. That's what it's already set to. Okay, let's try 10 mil then. Okay. Wait, that's clearance. Never mind. Clearance will leave. I want to make... Yeah, so the track width was actually already 10 mil. I didn't realize that. Okay, so I'm going to hit F to finish. And then... whoops. So X will come over here and then F to finish. So basically, I'm just getting it routed out the way I want, and then I'll let it finish it how, whatever makes sense. Let's try this. I should just be able to do this, and then just type Shift F. Yep, that's a little bit easier. So yeah, so that's what we'll do. I'm just gonna grab all of these. Let's undo everything. All I want are pads, so that I can select all of these pads and then Shift F. That's not how I wanted that to work. Darn it. Okay, I see why it got confused. Let's only do the... No, I don't... Darn it. I want them to come out a specific way, and they're wanting to come out another way. But that's okay. Nope. We should probably actually do those as zones on the top. That's probably what I'll do. I'm going to wait on the 5 volts. What I will do, though, is something like this. Just get that away from XN. All right. There we go. And then let's go ahead and do that one. And then I'm just going to do a via, because the backside, hold on. I'll wait on that. The backside is probably going to be ground. Okay. Now, for the top signals, let's see what's going to make the most sense for these. Yeah, see, I think they actually need to go up. So the question is going to be, if we do this, does that make the most sense? Nope. Yeah. So why didn't the other one work? What am I missing? I like these things to be a little bit symmetric. Oh well. Okay, so now I think I can select these and then do Shift F. Yeah. And then I'll go back and clean them up so they do what I want. That's pretty good. I don't think I've ever made use of the Shift F this much before. All right. Yeah, because like now what I want to do is I wanted these, there we go. See, I wanted them to be a little more spaced out, which I could probably mess around with the design rules and get that to be closer, a little bit better, but this will work. All right, it's not gonna be totally symmetric, but I think I'll be okay with that. Stop, 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 stop. There we go. Even though this stuff will pass DRC and it's probably manufacturable, I still like to do this little bit of cleanup just because I think it just looks nicer. And I'm just going to do these through Osh Park's normal service. I'm not going to do After Dark on these boards. I just don't think there's any reason to. There we go. Something's breaking down. Why aren't these not going the same way? This goes up and over. This one goes up and over. This one goes up and over. Then I come out here. I'm not sure why it's doing that. I think I see what it's doing now, but I don't know why. Whatever. I'll just, you know what, let's just clean it up and be done. Because we still have to do all the other sides. All right, good enough. We'll move that up. All right, we got to move that one up. Let's move this over. Move that up, move this over. Okay. All right, save that. Ooh, look at these. Yeah, let's... Is that going to mess up everything else? Probably. I should really just set the clearance to be bigger so that it will go right down the middle. Clearance, 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 clearance. Yeah, I see what happened. Now it's making a little more sense. Oh, I don't know what that was. I don't know why that opened up. There we go. No, come down here, come over here. I don't know why I am doing this. I am not normally this anal for a simple breakout board. Stop that. KiCad. If you don't behave, I have nothing I can do about it. All right, let's save that. Okay, so now this might get messy. Let's see how this is going to work out. I don't like that at all. All right, I know what I'm going to do. Okay, so how do we get this one over here and then this one into here? Yeah, after I did all of that, it was totally pointless because this is going to come in here, and this is because I'm going to end up going back and shoving all those others right out of the way again. All right, let's try something. I'm going to change my, I wonder if this will work. I'm going to change the clearance to be 12 mil. So what's the, hold on. Let's go to a really fine grid. So from here, so I'm looking at the coordinates that are just to my left. I'm going to, I hit space to reset that. So now I'm going to go over. So now these are at 0.45. So 225 minus 0.2, 0.025, 0.45. I think I want to set this to 0.45. No, it should be 0.45 minus 0.254, right? Because if I do that, it should only fit, nope, I need it to be more margin than that. So if I make this 0.45, whoop, no, that's not going to work. And then try to draw this through here. Yeah, that doesn't work. Nope. Almost got it. Almost got it. Nope. Wait a minute. Do I just set the two the same? And then does that just leave a perfect window? Yeah. Okay. That's what I should have done. Whatever. Okay. So what are we doing? This side goes which way? This goes up, over, and in. And then this goes up, over, and in. And this goes up, over, and in. It's still not doing what I want. All right. Nope. Yeah, so the finish is really cool because it's like it finishes from where you are, so you can kind of anchor it a little bit about how you want the trace to go. And then it just takes care of the rest, which is really nice. See, it's better than an auto router. It sort of routes for you. I already know not to do that, don't I? All right, because we still have to figure out then how do we get the other side. So this one now has to come through here. And this one has to come through here. And this one comes through there. And this one comes into here. And then this one comes through like this. Ooh, that's nasty. All right. Okay. Bum, bum, bum. All right, those lines are done-ish. Now let's come back and clean these up. Oh, XE should have been up and around like this. The 5, yeah, see, 5 volts are going to be a problem. We may just break the ground plane there. That might actually, ooh, that won't work though. That won't work. Okay. Let's clean these up and then figure that out. Okay, so whatever I changed, I don't like what I changed. So this is probably 8 mil. Yeah. Okay. All right, come on. Let's do like this. We'll do that. Let's bring these out here. All right. Why am I shoving weird now? Do I have a whole bunch of DRC violations at this point? Yep. That's why. That is why. Yeah, I disagree. The free route especially does an absolutely abysmal job. So I don't think the cleanup would have been any faster if I had let it waste my time. I think so little of auto routers. At least the kind that like work with KiCad. I mean, the only way to this is okay. I screwed up. I know what happened. It's because I changed the DRC clearance, and so it messed everything up. Let's do delete all markers. All right, so let's just do this the right way. I said, let's do this the right way, and I immediately do it the wrong way. Nice. All right. Why is it doing it that way? This should have come up. Okay, so this should have come up to about here. And then this should have come up like this. Yeah, okay. All right, I think I see what I have to do to get this to be happy. I mean, this is the fundamental problem with auto routers is that they don't notice anything about patterns, which is what makes them so useless, in my opinion. The fact that they're not able to go, oh, wait a minute, if I follow this kind of pattern, then I end up with this not, oh, what did I just do? Of course, they don't do that either, so. Oh, James. Sometimes I think you do this on purpose. Let's move this, okay. All right, so this is going to come up, around, and over. And this is going to come down, around, and up, around, and over. Yeah, about that. There we go. I think I've got it now. There we go. Yeah. Just like all routing tasks, if you don't route a board at least twice, is it really routed? I don't think so. I don't think so. Okay. Save that, and then we can go up, over, around, and through, down, around, and up. Yeah, that's going to work out. There we go. The good news is I don't have to pay attention to anything because DRC will let me know all the mistakes I made. That should be a t-shirt. I don't make mistakes. I just make DRC violations. Get it? I don't know if it's actually that funny. I did not think it'd take this long to do this first board. Now, how do I want to get ground? Okay, this I think we can still just do it this way. All right. Okay, so before I do anything else, I want to do a quick DRC check and see if we're getting clearance violations. Wow. Okay. Where else? Okay. I feel like there should have been more arrows. Oh, unconnected items is what's so high. Okay, I can handle that. I know why there's still so many unconnected. Because we haven't done 5 volts or ground yet. Okay. Yeah, I did actually on the Apple II project, the Mega 2 project, I did actually use an auto router one time, and it's because between my CPU board and the backplane, the middle connector was twisted 90 degrees, and so I made an interposer board that swizzled the signals into the correct order, and I just said to hell with it and had the auto router figure it out, because it was just a nightmare. So I have actually used one for a board that I just straight up did not want to route, and it did fine. I mean, the signals are all like 1 megahertz, so, and I don't know, 10 nanosecond rise times, so it wasn't like it wasn't a really big deal. All right, I'm just gonna take the defaults. I don't really want to. Let's. There. All right, let's try this again. I want it on the back. I want it to be ground. Call it ground, and then I'm just gonna leave all of the defaults for the moment because I don't want to mess with it. Let's see if I'm happy with what this results in. Double click to close. B to fill. Yeah, that looks pretty good. I'm happy with that. Now we got to figure out how we're going to get 5 volts to a few of these things. So, well, I didn't even think about this. This is the same. Okay. Yeah, actually, I know how we're going to do this. Okay. So let's get this back to like something like this. All right. And then we're going to do that. Okay. That should take care of that one. Now, how are we going to get XE? Oh, I know what I'm going to do. Same thing I just did. I'm just going to take it up around this way. Basically, what I'm trying to avoid is cutting off or getting too close to that clock signal, which actually I think I would rather come around this way. There we go. All right, so that's taken care of. But then, oh, I haven't done anything to connect the 5 volt lines, have I? Yeah, that's going to be tough. That is going to be a toughie. Especially right here. So I think let's do this. Let's try this. Just ignore them. That normally fixes the problem. Wait, ignore what? It's been a while since I looked up. Let's make these. Can I don't think we can make it this big, but we're going to try. And then net class pattern plus 5 volt. Nets matching plus 5 volts. I want that to be power. Okay. And then now I want this. Yeah, that's not going to make it through there, is it? However, okay, I got a better idea. What if, hear me out, we just said, give us a plus 5 volt, and we'll just call this plus 5 volt zone that we take and go around. Oh, I can get rid of that line. And just do this. All right, and then let's take this trace, delete that, fill that in. Fail. Our spokes did not work. Okay, that's okay. That's okay. That's okay. We can optimize. We can optimize. Also, nope, that's not true. I can't say that. Never mind. Okay, so now what we got to figure out is how do we get, so our clearance will stick with 8 mil, minimum width 8 mil, thermal relief gap 0.1 millimeter, 0.2 millimeter, and thermal spoke width of 1 millimeter. Okay, there we go. That looks much better. Yeah, now we got nice good fills all around those grounds. Okay, so I think we can do something similar up here. In fact, I'm just going to, yeah, we'll just draw it again. But I don't like this idea. I'm not a super big fan of this idea, but I'm going to do it. I'm going to put on the front copper 5 volt net. No, I'm sorry. On the back copper 5 volt. Zone priority 1. Leave those the same. And then we're going to come around here to here up to here. Yeah, not my favorite way to do this. But I don't see a choice, because what sucks about this is we only have this really thin bit of copper. I guess I could actually maybe bring this back a little bit. What's the farthest I can bring this over without it? Yeah, that's pretty good. If I come all the way to here, that's too much. That looks good. What I don't like about this is I only have these thin strips of copper on the left and right side of this that are ground. However, the ground, However, the ground is also connected from the target. So the target actually binds those together as well. So, not my favorite way to do this, but I think it's okay. Hey, the Fet, welcome. Thank you for the kind words. So this is, I'm making a logic analyzer adapter for a computer called the CERBERUS, which is from the Byte Attic So it's a board that has two processors, a 6502 or 65CO2 and a Z80. And then you select between the two using the BIOS. Select between the two using the BIOS. There's 3 CPLDs or programmable logic chips that tie everything together, with one of them being the video controller. And so one feature of this computer is that it has a 40-pin header for expansion cards, which contains mostly the address and data lines, plus clock and a couple other things. And so I'm making an adapter that will plug onto that. So this will just plug right into that socket. And then you can plug an expansion card on the right side and connect wires to a logic analyzer on the left side, or vice versa. Doesn't really matter. Yeah. So that's what we're making. All right. While we're in here, and then I'm going to make a version of this that will, with a ribbon cable, connect to a digital discovery logic analyzer, which is what I did with the Mega 2E. Is I made a logic analyzer thing that could just plug right into it. I really like it, but I realized not everybody has one of those, and I still think a board like this would be useful. So that's why I want to make 2 versions of it. You know, why not? So graphics, so one thing bothering me, that's still bothering me, but now I'm kind of set. This is about the size that this is going to end up being. I want to round the corners of this board. So I'm going to select the polygon I drew on the edge cut layer. I'm going to right click, and then we're going to do modification, fillet lines. I'm going to go really ridiculous and say 5 millimeter and just see what that looks like. Yeah, I like that. It's so ridiculous, but it looks so cool because it's rounded off. So yeah. Can it run International Karate? Which one is that? I don't think I ever played that one. Actually, the funny thing is Bernardo, he's the guy that designed it. In his video talking about the basic features of the computer, I think approximately 500 million times, he says that this computer is not designed for video games. And I just feel like saying that so many times, like all I want to do now is write games for it. Like, it's like, really? Okay. If you say so. I'm only kind of kidding. So, all right. Okay. That actually looks pretty good so far. Let's save this, and then let's, wait, do we have unrouted down to 0? I forgot to check that. No, unrouted is at 2. Okay, so let's do DRC. We'll run this and see what's connected. So it's saying this still has no connection to... Huh. Missing connection between pad 35. I don't understand. I mean, it's a through hole. Wait, is it saying it's... I know what it's saying. Oh, yeah, right. The 2 5 volts aren't connected by anything. Balls. Well, I only know one way to fix that, and that is to yeah, actually, this is the only way I can think to fix this. Is I'm just going to draw a polygon on the front, 5 volts, zone priority 1. So my 5 volt zone is priority 1, my ground zone is priority 0. It just affects how KiCad handles it when zones overlap. So in general, I missed the one that I wanted. So in general, you want... Oh, what is going on? Really? Really? Now are you happy? Whatever. 5, 1. I'm going to leave everything else the same. I'm going to come up to here. And then I'm going to come around this way. And I'm purposely leaving the card because I want that whole area. Now, did that side get filled in at all? It did. So next what I'm going to do is I'm going to say that's a little ridiculous. I don't like how that 5V is hugging everything. So here's what we're going to do. I'm actually going to draw this one back here a little bit. And then I'm going to add one more zone just around the 5V pads, which is actually going to be 2 more zones because I know how to count. Okay, so now that's connected. And then same thing down here, maybe. This already overlaps. I'm just going to draw this off the edge of the board. All right, there we go. Okay, so that takes care of that. What else is missing? What was this other one? I must have missed one of the connections. Yep. Yeah, I forgot to actually wire that one. So let's do an X and then bring this in here, drag this back a little bit. Ooh, that optimizer is working hard now. Wonder why. Oh, I know why, because I have my grid so high. There we go. This will help. There we go. That's better. All right, is that the only one? Okay, now we're at routed equals 0. Oh, you can't see it, can you? It's down here. Oh, look at that. So routes are unrouted is 0. So that's the good first step. All right, so let's go into our, wait. Let's save this and save that. Make sure those are both up to date. Actually, you know what I'm going to do, because this is kind of a good milestone, is close everything, commit this, unrouted 0. And yeah, I am working in the main branch because I just created it, so why not? I don't know. I probably should have created a branch, but I didn't. Okay, come back into the PCB. Oh, teardrops. Ooh, I like the way you think. Yeah, let's do tear. Oh, well, I tell you what, let's run DRC one more time just to make sure that we don't have a major issue before we add teardrops. All right, DRC is happy. Okay, yeah, let's do teardrops. I like that idea. Yeah, and actually in my KiCad 8 video, I feel bad now because I seriously thought this teardrops support was added to version 8, but it was added in version 7. And 8 just added it to the board setup and kind of cleaned up the UI. So yeah. So edges, curved. And then I'm just going to say okay. And then I think what we need to do is, can we just go into edit teardrops? Vias. I don't think track to track is what I want. Add teardrops with default values for shape. So I'm going to say okay. That feels like it did nothing. Yeah, it did nothing. Wait. Yeah, okay, now I remember. So there's 2 things. First, the teardrops get added as a zone. So like, and I should have realized I set myself up for this. So if you have your zone out, if you have the zone set to outlines, it doesn't look like teardrops did anything. But if you used fill zones and then fill the zones, you can actually see how all the teardrop stuff happened. And that looks pretty cool. Now, technically, as I understand it, this improves the manufacturability of the board because there's more copper around the via. It helps to account for if the drill is slightly off, there's more copper available. And then there's some signal integrity issues or signal integrity things that it affects. However, at the speeds that this board runs at, it's probably not a big deal. All right. So we ran in DRC again, no error. I'll take that. Okay, I got one more we're going to try. Let me commit this real quick. We're going to try one more thing. I'm going to curve the traces. I just want to see. Add it teardrops. We also need to add some silk screen, but we'll get to that. All right. Tools, plugins, round tracks. Now, KiCad does have some rounding stuff built in. However, I don't really care much for it. You know what? There's no point in doing this because I'm not going to do it through After Dark. Hold on. So we saved it, right? Okay. As long as we saved it, I'm going to run it anyway, but I don't think I'm going to keep them. And run. Okay. So it does actually a pretty nice job. So the round tracks plugin is a post-process, regardless of how you look at it. But it really does a nice job of giving the traces like a hand draw. Now I want to do this in After Dark. Damn it. Because it just looks really nice. Except right there, what happened here? The teardrop overlapped. Now, the one issue with this plugin is it doesn't always make things that are DRC compatible. Yeah. Okay. All right. I'm not going to keep it. I don't want to mess with it. It's not going to matter. We're not going to be able to see them anyway. The round track for a board like this, I don't think it makes sense. This needs to be a functional board, not a pretty board. So we'll do that. We still have our teardrops. I'm going to run DRC just to make sure. Oh, shoot. Close. Close. Run DRC just to make sure I didn't mess anything up. Just ignore the DRC. Yeah. Yeah. You know, we actually could. It's probably actually in this case, we're probably actually fine because I have my DRC rules set, I think, to 8 mil, and I think Oshpark can do 6 mil. So we're probably actually fine, but I'm not gonna. I don't. It doesn't matter on this one. Okay, so now let's go add a couple of logos. So I'm gonna do file. Let's see where we're gonna put them. Let's add Oshpark Osh Hardware Lobo. Nice. Almost fits. Actually, that's going to fit just fine. I do want to actually turn these off because that messes me up every single time. Oh, wait. We can't put that there. Nope, that won't work. Because I'll tell you what we're going to do. I totally forgot. I said I would do this, and then I didn't. So on the front silk, here's how I like to mark grounds. Is with a polygon. And we're going to fill it, not fillet or fill it, but fill it. And then I'm going to do this, and we're going to do, now why aren't these perfectly aligned? Stop it, stop it, stop it. Okay, just realized it doesn't matter because what I need to do is go to text, ground, knockout, thickness 2, enter. I think though if I do this, yeah, it'll cover it up no matter what. So how can I get there? Ooh, pretty. All right, I think there's one more up at the top. So I like to highlight my grounds with a, just like I'm doing here, where it's a filled in polygon, because I think it looks nice. I'm going to undo that, and then up here we're going to add XE, and then over here we'll add plus 5 volts. Okay, and then for the rest of these I'm just going to add the polygon, and this is why I like to do this after everything, because watch what happens. I mean, DRC is going to give us a ton of silkscreen warnings, which is fine. It's just if there was an actual issue that I cared about, then it would be hard to see it, because like now our warnings are going to go like, yeah, every one of these generates warnings. And I don't necessarily want to ignore them early in the project, because they may actually be a warning I care about. Like I may be overlapping something without realizing it, like two designators on top of each other accidentally. So yeah, so so that's why I like to do this as a post-process step. And then the other thing, and I think this is probably the more critical one, is we're going to put these on the back side as well. Because I always like to be able to just flip the board over and see where the grounds are. Oh my gosh, stop that. Stop. Okay, fine, whatever. I don't want to argue with you. All right. So I'm just doing copy, or select them all, copy, paste, F to flip, and then just place them down. This is kind of one of those things that I feel like if you do this, it makes your board look just slightly nicer. And then for this one, all right, let's go take a look at that. See straight off the bat, you can easily see where the ground pins are. I really like that. And then back here, that looks really good. That looks really, really good. I do think one more thing we need to figure out is how are we going to label the backside? The problem is on the backside, like what I actually want to do on the backside is take this, flip, and then I got to go align to the left, and I want these to line up to about here. All right, and then I want to grab these, flip, and I want to align those to the right and move those all right. So let's see. How does that look back here? This is kind of messy, but we can clean that up. Yeah, I don't super like that, but we can easily clean that up. And then is that right? Yeah, I like that. I like that a lot. So, okay. So what we'll do is on the back side, we're going to delete. So let's kill the front side silk. We're just going to delete this because that doesn't look so good. And then my next thought was to draw a line. There. I think this is going to be a little bit cleaner. Yeah, I like that. Because then that way it's like, okay, This clearly is these pins, and this is clearly those pins. This is ignore that. I wonder if we should do the same on the front. Yeah, I like that. Smooth. Okay, let's grab this, and this one and move this up to there. Grab this, this, and this one and move that up to here. All right. Yeah, I like that. I like that a lot. Okay, and then down here on the back side, let's do a view, flipboard view. So we're looking at the back. Let's right click and do show only back layers. No fab. Who cares about the fab? Okay, and then let's do a text box. And we'll just say, geez. Who pasted all that stuff? Gosh. Ooh, I lost everything. Okay. I want the okay. CERBERUS 2100 121 LA adapter Rev 1 Bald Engineer. Oh, excuse me. I made a noise. Dumb V is in our way. All right. If we do that, is that right? Yeah, okay. Not super happy about that, but that looks better than nothing. Okay. I would have liked to have put some logos on here, but we ran out of space, and I think that's good enough. So there we go. Now we have our logic analyzer adapter. Our generic one anyway. Okay. So cancel. Let's save this. I'm going to check DRC one more time because I feel like there's always, and see, like our warnings are through the roof now, but it's because of those polygons. So they're fine. All right. So close that. Save this. Let's go ahead and do a generate Gerbers. And the output directory is going to be the current directory, but we're going to call this 121 Gerbs version 1. And it'll ask, do we want that to be relative? Yes. So we'll get copper, paste. Don't really care about paste, but we'll go ahead and let it happen. Silk, mask, edge cuts. That looks good. Everything else over here should be the same. Plot reference designator. Yeah, okay, whatever. Okay, so we'll plot those. Then we'll generate drill file, Excel, X2, blah, blah, blah. And that'll go into 1-to-1 Gerb, generate that, close that, close that. All right. And then for fun, let's get a quick, I want like a, something like, yeah, maybe we'll just go like this. All right, let's save JPEG. Export current view as JPEG. Rev 1. Save. All right. I guess I could have. Can I reset? I just realized if I close this, does it reset it? There's probably yeah. I should have used this one. Nope. This one. Nope. This one. I should have done it like that. There. All right, let's save that as not a PNG. That's too big. All right. Replace that. And then, nope. And then let's save that. Okay. Beautiful. All right. So that should be ready to get fabricated. Okay. I think we'll stop there. I want to do one for the digital discovery, but we're going to end up ripping up half the board and relaying it out. And so, yeah, we will just go from there. So I'm going to do stage all that. And then we'll say this is 121 Rev 1 ready for fab. Whoa, that was inappropriate. Round tracks config. Oh, we can actually shoot. On tracks config, we should unstage that. The Gerber files all look good. Okay. All right. Cool. So I'll get that sent off. So hopefully in the next couple of weeks, we'll get that back. And then I think next week we'll make the one for the Digilant. Yeah, that'll be a good next week project. So, okie dokie. I mean, I guess we could have just done one. No, I wanted the one-to-one first. So, oh, what's not committed? Oh, this one. We can just show and explore. We're just going to delete this file. Cool. All right. So for those that don't follow the Element 14 Presents channel, there will be a new video from me tomorrow. And then next week we'll be streaming same time, same bat channel. So subtract 2 hours from now, and that's when we'll start next Thursday. Unless I get free time, which based on my current schedule, not going to happen. We'll be doing the digital discovery version of the connector for this computer. And then probably by the following week, it'll come back and maybe we'll plug it in and actually use it. So, all right. Thanks for hanging out. It's been fun. I appreciate it. Thanks for all your help, your support. For those that don't know, we do have a Discord. If you want to come hang out, talk retro stuff, ask capacitor questions. Next week, I'll have my capacitor seminar. If you would like to, so next Wednesday at 1 p.m., I completely forgot, MLCC to polymer. I'm doing a webinar with Hioki USA where I'll talk about capacitor measurements. So you want to sign up for that and learn about some capacitors next week. That'll be really fun. Wow, we're going to be really busy next week. All right. Please, I hope you find time to work on something you enjoy. And if you do, remember to share it with others. All right, guys. Take care. Catch you later.